yesterday we had completed till Lenz's law. We have to start with motional EMF. Now, what is motional EMF? Motional EMF is basically when there is a motion of the conductor, then the EMF which is produced, we call it as motional EMF. So the EMF induced across the ends of a conductor due to its motion in a magnetic field is called the motional EMF. Now, its derivation is very small. You can understand. This is a rectangular. These are rectangular tracks, railway tracks. The way railway tracks are there, no? Similarly, these are also tracks which are laid down, on which there is a sliding conductor. This PQ is a sliding conductor. Length of this conductor is L and velocity is V. This separation is X. All right, now this conductor moves on this. So length of the conductor I have taken it as L and the velocity with which the conductor moves is V. We have taken X as the length of the loop inside the conductor. Now see, when we are talking about magnetic flux is equal to B dot A, which can also be written as area. How can we write the area, class? Area of this part, length into breadth, that is L into X. That is how you can write the area. So this will be L into X, correct? Because area is equal to L into X. EMF is equal to minus d phi over dt, which is equal to minus. What is d phi? This is d BLX over dt. This is equal to minus BL. You can take common. You are left with dx over dt. Now, what is dx over dt? Rate of change of displacement, which is velocity. So, EMF is equal to B L V. This is the formula for EMF. What is the velocity here? Velocity is equal to minus dx over dt. So, why are we writing minus sign? Why are we getting minus sign in our calculation? Because this tells you that velocity is in the direction where EMF decreases. Wherever EMF is less, wherever EMF is decreasing, there is the direction of velocity. That's why we have this minus sign. All right, so E is equal to B L B. This is the main formula. So what are all the variables which are mentioned? E is the motional EMF. B is the magnetic field. L is the length of conductor. V is the velocity of conductor. Now, if we have EMF is equal to BLV, some more formula we can have. If EMF is BLV, then current will be BLV divided by R, where V is the velocity and R is the resistance. This is about the current in total. When we're talking about force, it's BIL. B, what is I? I is BLV by R. BIL. So this is equal to B square L square V divided by R. What is this? This is formula for force. Power is equal to force into velocity. What is force? Force is B square L square V by R. And what is next? Multiplied to velocity. So final formula for power is B square L square V square divided by R. This is the formula for power. All right, write it down. Write down the entire derivation. Question also we'll be practicing. First write it down. Then we'll see a question. This question says that an aircraft with a wingspan of 40 meter flies with a speed of 1080 kilometers per hour. So first thing, if this is given in meters, this has to be converted into meter per second as well. In the eastward direction at a constant altitude in the northern hemisphere, where the vertical component of the magnetic field is 1.75 into 10 to the power minus 5 Tesla. Find the EMF that develops between the tips of the wing. Very, very easy question given in your NCRTC. What is velocity? Velocity is 1080. That is multiplied by 5 by 18, which is equal to 5400 by 18. This is equal to 300 meter per second. So this is the velocity. What is the magnetic field given? Magnetic field is 1.75 into 10 to the power minus 5, which is given. So you have to, and length or wingspan is already given 40 meters. So EMF will be BLV, which is equal to 1.75 into 10 to the power minus 5 into 40 into 300. This should come around 0.21. Someone cross check also this. (0.21 volts. Write it down. Okay, just one thing. You have the concept of eddy currents not included in your syllabus. Eddy currents are basically whirlpools which are formed. If you have a very thin sheet or if you have a block, even if I tell you that the edges are made curved or something, the eddy currents have the tendency to travel like this. They have the tendency to travel like this in whirlpools. This is not included in your syllabus. No need to remember it. They are known as Foucault current, but I'm just briefing you. They are used in induction furnace, electromagnetic damping, electric brakes, speedometers. Details, formula, no need to remember. Just at the corner of your notebook or after writing this, just make a note. Write it not included in the CBSE syllabus so that you don't revise it for the exam, and just write it so that it is you will just have a brief idea. Yes, I'll show the question. Write down the question, those who haven't. Then straight away we'll start with induction, our last topic for EMF, EMI. Class, what is meant by induction? So, induction we have studied in the first lesson also, that induction, if you remember methods of charging, there was charging by conduction, charging by friction, charging by induction. So, induction means you are inducing something, right? Something is being induced, something is being produced. So, self-induction is, see, this is a coil, the magnetic flux or magnetic field, because of magnetic flux, both are increasing, suppose. So because of this increment in the magnetic field, there is an, see, whenever there's a change in magnetic field, wherever there's a change in magnetic flux, according to Faraday's laws, we have studied that there will be induced current in the circuit or induced EMF in the circuit. Now see, the flux or magnetic field of this coil is only increasing and induced current is being produced in this coil only. Understood? Same coil. That's why we call it as self-induction. In mutual induction, you will be having one coil whose magnetic flux or magnetic field will be changing and current will be induced in the second coil. That is known as mutual induction. In self-induction, it's the same coil. All right. So self-induction is a phenomena of production of induced EMF in a coil when a changing current passes through it. All right. Now see this case. See, this is a coil which is connected to a switch, to a battery, and the wire is closed. So what happens as soon as this is closing switch, means the switch is on. When the switch is closed, the current increases from 0 to maximum value. If current is increasing, why? So what is happening? Magnetic flux was increasing. There was a coil, current was being produced. So when you close it, current increases, flux increases, there is an EMF which is produced. Similarly, when you open the circuit from a maximum value of current, the current becomes back to 0. Current, flux, both decreases. But can you see this is happening in the same coil? Current is also increasing, flux is also increasing. Here, flux is also decreasing, current is also decreasing, EMF is also being induced. So this is happening in the same coil. That's why we call this as self-induction. So on what factor will it depends? It depends directly on the current. If the current is very much, flux will also be very much. If the flux is very much, current will also be very much. If it is less, it would also be less. Flux is directly proportional to current. This you have to remember. Magnetic flux is directly proportional to current. So here the constant term that will come is L. That is the coefficient of self-inductance. This is known as coefficient of self-induction, or you can also call it simply self-inductance. This term is mostly used. Self-inductance. What is this? This is magnetic flux. This is magnetic flux. I is the current. Fine. So this is directly proportional to it. If suppose inductance becomes equal, or let's say we take the current as 1 ampere. So flux will be equal to the inductance. So you can further say that a self-inductance is numerically equal to the magnetic flux. Both are equal when unit current passes through it. All right, when unit current passes through it. So what can you conclude about it? See, self-inductance is numerically equal to the magnetic flux when a unit current flows through it. We have studied E is equal to minus d phi over dt. So see, E is equal to minus d phi over dt. What is phi now? Phi is equal to Li. So this is minus Li instead of phi over dt. Correct? Instead of phi, I have written Li. So take L common. What are you left with this? So final formula of EMF is minus L di over dt. This is what is meant by self-inductance. Coming to the units also, when you talk about the SI units of it. See, SI unit when you're talking. This is firstly 1 voltage because of EMF and di over dt. So current per second. Whatever is it, you have to remember we have the unit known as Henry with the symbol H. Use this. And from this, if you remember class 11 dimensions, L is equal to phi divided by current, which is BA divided by current. So M L squared T to the power minus 2, A to the power minus 2. This is the dimension. One more thing is there for a long solenoid, but I think first you should write down this, then I'll discuss that. This is clear what is meant by induction. Magnetic flux, magnetic field is changing. And what have we studied till now? Whenever there is a change in flux, there is an EMF induced. That was your entire Faraday's law, correct? Within the same coil, if this is occurring, we call it self-induction. If this is occurring if there is one primary which is producing and induction is being there in the second one, we call it as mutual induction. This basic concept is clear regarding induction is very important. From the entire EMF is something is very important, or when you are revising, then I will suggest you that start from induction. Once you are thorough with the syllabus, at the last moment, no, when you revise, when you are done with everything, we start revising the important part. Then for that, I'll suggest you that it's better if you revise, start revising it from here, induction, then go as per we have started. Is it clear to all of you? Yes or no? Do you want me to repeat some portion? Clear to Amna? Others? Deborah, Rajita, Sidra, Fadil? Not understood?
Understood, ma'am.
Understood, no? Okay. Write it down. See, self-inductance of a long solenoid, when we talk about, there's just a small modification. You know, B is equal to mu naught Ni, where N is what? N is number of turns per unit length, correct? And what is magnetic flux? Magnetic flux is Ba. So flux here would be, for B, substitute the values of B, mu naught Ni into A, correct? Okay, what is N from here? Capital N from here is small n into L. N is just the number of turns. Small n is number of turns per unit length because L is the length. Now magnetic flux linked with entire solenoid is equal to flux linked with each turn into number of turns. If you have flux for each turn, if you multiply it with the total number of turns, see mu naught Nia multiplied to N into L. Now this quantity will give you the flux linked to the entire solenoid. This is number of, if you just keep it, it would be just for a single turn. What if there are so many turns, right? So flux is equal to mu naught N square IAL. Also, we have the value phi is equal to Li. Can we equate these two? Both are ultimately giving us the flux. So this is equal to, if you equate 1 and 2, you will get Li is equal to mu naught N square IAL. From here, not AL, sorry. There is no LO this side. So this is, this cancels I. So inductance has one more formula, mu naught N square A. Just in case if this is needed, solenoid is given to you, or you can write N square by L square into area, where you put the value. Question also C. This is that a 12-volt battery connected to a 6 ohm 10 Henry coil through a switch drives a constant current through the circuit. The switch is suddenly opened. If it takes 1 milliseconds to open the switch, find the average EMF induced across the coil. So see, E is equal to minus L di over dt. This is the formula. Look at every term. What is EMF given? We don't know that. We have to calculate. It is saying find average EMF. So we have to find out this. What is inductance given? 10 Henry. So inductance is already given as 10 Henry. Value of current? Nothing is mentioned. 12-volt battery. Okay. So see, we know the voltage is 12 volt. Resistance is 2 ohms. So we can apply V is equal to IR. Which law is this? Ohm's law. If you apply Ohm's law, at least you can find out the value of current. Current will be equal to V divided by R. V is 12, resistance is 2, current is 6 amperes. Correct? This is what is given. Resistance is 2, no? Okay, no, resistance is 6. Sorry. Resistance is 6. So this will be 2. Current will be 2. 6. This is 2 amperes. So current is 2 amperes. What is time? Time is given as 1 milliseconds. That is 10 to the power minus 3 seconds. So EMF will be 10 into 2 divided by 10 to the power minus 3. This is equal to 2 into 10 to the power 4. Tell me, this question was easy? Clear to all of you? Rajita, you are understanding everything in today's class? Rajita, you have not responded.
Yes,
okay.
ma'am.
Okay, good. Write it down, write down this portion. Now then we are left with mutual induction. That shouldn't take so much of time. If you have understood self-induction, mutual induction is very easy. Please attempt your after class assessment. And then mutual induction is a very small topic. We'll start with AC in the next class. Mutual induction will just take 10 to 15 minutes. Then we'll straight away start with AC.